It's pretty amazing how ultrasound uses like basic physics to show us what's happening inside the body. Once you get those principles, those images really start to make sense.
Okay, so let's start with something basic. One of the first practice questions is all about sound waves. It asks about those regions, where the particles are less concentrated. What are those called again?
Those are called rarefactions. So sound waves are basically like variations in pressure that are moving, right? Imagine a slinky and you're pushing and pulling it. You get those areas where the coils are all bunched up and then areas where they spread out. Those spread out parts, those are the rarefactions. Ultrasound uses those, the compressions and rarefactions. It sends out these pulses of sound waves and then it listens for the echoes that come back. Kind of like how bats use echolocation.
So it's like a super fast game of like acoustic ping pong using those compressions and rarefactions to like make pictures, right? This next question is about how those sound waves actually travel. They mentioned this thing called propagation speed. What is that all about?
Oh, propagation speed is just the speed at which sound travels through whatever material it's in, the medium. Like, think about how sound is different in air versus water. That's because the speed changes based on stuff like the density or the temperature. Those are called acoustic variables.
Okay, that makes sense. So like the denser something is, the faster sound goes through it. So how does all this relate to like the actual ultrasound machine? The next part in the practice materials is all about transducers. I see phased arrays, annular arrays. To be honest, it's a little overwhelming.
Think of transducers as the heart of the whole system, right? They're what send out and then pick up those sound waves we were talking about. They change electrical energy into sound and then back again. It's like they're both the microphone and the speaker. There are different types of transducers, each with its own pros and cons, but the ones to really know for your exam are phased array transducers. These are really cool because they do something called electronic steering, so no moving parts. Imagine like a bunch of tiny little speakers, and they're all firing sound waves, but with slightly different timing. That lets them sweep the sound beam across the body, which is how we get those real-time images on the screen.
Wow, that's like a choreographed dance of sound waves. But there's a note here about grating lobes. What are those, and why are they important to know about?
Grating lobes are kind of like a side effect you can get with phased array transducers. Basically, there are these extra beams, sort of unwanted, that can pop up off to the sides of the main beam. Like imagine shining a flashlight, and instead of one beam, you get these little stray beams coming out at weird angles. Those are like grating lobes. And the problem is they can sometimes mess with the image, make things look blurry or distorted.
So it's like those grating lobes can create these little ultrasound illusions, right? That's a good way to think about it.